Hope this doesn't.
No, not distracted. I'm just trying to figure out.
It shouldn't matter too much because you're the one presenting. Here we go. So, all right.
Just so you know.
Good. I'm Abjay.
Rob, pleasure.
Pleasure. Thank you so much for volunteering to come by. OSD as well.
I mean, I volunteered before I realized how hard it would be to get here, but it's a.
It's not a great day to cycle. Did you cycle?
I did,
You
yeah.
cycled. That's very impressive.
You
Okay.
hit the 20K though?
I got 25.
There you go.
But it was against the
Amazing.
wind.
Okay, everyone's
So
fantastic.
that means when you're flying back, you'll be good.
True.
Right. Okay. So
You'll be live streaming.
Are you all set up?
we are set up with live stream from YouTube. The live microphone is currently in Charlie's hand.
Yeah.
And
Oh, the one thing, cameras on, that's the
Yes.
controls for the slides and the off. So
Yeah,
whenever
okay.
we do the spotlight vote.
Yeah.
Next slide, next slide.
I can move the camera if you'd like.
Yeah. All good. So, do you want to kick this off?
Yeah.
So there's this, and then if you'd like to switch over, I think that if you just start sharing, it'll
Yeah.
cut over.
Yeah.
Yeah.
And the people on, oh no, who's on?
Sorry.
Who's controlling the slides?
I'll be on you.
So, but this computer, right?
Yes.
Yes, it'll just be the left, right buttons. Yeah, should otherwise be.
Well, the.
Yep, lovely. Okay, we're good. I might just take maybe like the first 2-3 slides.
Yep,
just,
that's what
get
you-
everyone-
So,
Great. All right, we are live.
you.
You know, the format of the workshop? Have an interest, like? Eyewitness.
Right. If you want more lights, you can just tap that in.
Oh, yeah, okay.
All right. Thank you for coming by, everyone. We're probably going to get a head start then on our OOSD, Object-Oriented Software Development workshop. Thanks for coming by. Sorry, Charlie, would you mind just tapping us by?
Oh, yes.
Okay, great. So we have Rob and Charlie, who have both very generously volunteered their time today to facilitate the workshop. But before we get started, I'd like to make an acknowledgement of country, acknowledging the First Nations people of Australia, upon whose unceded land we conduct today's workshop and in which we learn and work every day. Okay, next slide, please, Charlie. Great. Okay, so very quick disclaimer before we get started. While we are very lucky to be joined by two very illustrious past tutors of the subject, we cannot in any capacity guarantee that the subject we cover today will be on the exam or is representative of what is on the current exam as directed by the teaching staff of the University of Melbourne. This is because we're organizing this in an independent capacity as students, as members of the Computing Information Systems Student Association, CISSA. Just one more slide. But who is CISSA? You probably know of us. You're here. Quite a few of you are from CISSA themselves. But CISSA is basically the premier student association for computing at University of Melbourne. We run a variety of social events, educational events, career opportunities, and upskilling opportunities at every week, whenever possible. And the community at University of Melbourne has never been more alive. We have our link tree just up there. If you want to take the time, scan the QR code, sign up to the mailing list, become a member, and keep in touch with us on whatever we get up to week on week. But that's a lot of prelude. We will get underway, I think. All right, I'll hand over to Rob and Charlie to get started.
Thank you, Avjay. So just to get ourselves started, there should be one more name against that because it is not just me on this one. So hi everyone, my name is Charlie Ding. I graduated with a Masters of Software Eng, now working as a software engineer at Airwallex, and I'm glad to be here to try and help you guys revise on object-oriented software development. But before we get started, I also would pass it back over to Rob, who will be helping us along as well.
Yep. Beautiful. Thank you, Charlie. So most of you probably don't know me or Charlie for that matter, but I'm a very similar story to Charlie. So was at the uni, did my master's in software eng as well. During that time, we were both actually tutoring the subject, so we are pretty familiar with the exam and the content. So it's a good opportunity to ask any questions. And now we're both working as software engineers, so clearly the subject helped. Yeah, so I think maybe Charlie wants to touch on format, but we just wanted to sort of emphasize. So we're here to answer questions. We do have some content to cover. And then we'll be spending some time going over practice exams. So I think the sort of indicative split is the first hour, we'll kind of talk about content. Next hour, we'll do practice questions. And then within that first hour, we do have some slides, but it's a really good opportunity to ask any questions that you're unsure of. And we're sort of here to help and support. So we'll follow a very loose structure, but we're trying to keep it maybe as interactive as we can. So feel free to ask questions. Maybe if there's something you don't understand that you need to, it's a good time. And if you've got a question, probably everyone else has the same question. And I sort of say that all the time, but there's not such a thing as a stupid question, which maybe you've heard, but feel free to ask, and we'll do our best to answer.
Thank you, Rob. All right. Shall we get on to the next slide? Hopefully there's I don't remember if there was. I'm not sure if this got updated, but let's move along. Okay, this used to be a question thing. All right, here we go. So this was supposed to be today's agenda. As Rob already alluded to, it's really important that I guess this first half, even though it says reviewing of challenging topics, everyone's opinions on what challenging topics are is different. Okay, so here we've tried to sort of collate a bunch of different topics. So this includes exception handling. We also be going through generics. How do they work? And also, I think one of the most sort of commonly asked sort of concepts that please cover this will be design patterns, which we'll hopefully try to get through at the end as well. But before we get on started, just based off those sort of the concepts that I just alluded to, was there anything, any other topics that maybe someone in the audience, someone you guys here, or maybe even online wanted us to cover as well? Anything in particular? Yeah. Name the first thing. I don't know. What are you up to in terms of revision? Maybe that could be a good start. You could say classes or objects or even Java for that matter. Yes. Unit testing. Yep. That'll be a great start. Great start to that. So I guess we can definitely talk about in terms of both it from a more of a, I guess, high level perspective in terms of what we should be going about testing, but also we can also touch at base in terms of actual implementation as well. Anything else? Design patterns, of course. Okay, we got 2 votes for design patterns on that one. Definitely a commonly sort of asked question to cover, and we'll definitely be going into a lot of detail about design patterns later on towards the concepts. Anything else? Otherwise, we're going to be focusing on those 2 extra topics. Yes? Yep, can do. Inheritance in terms of both as a concept, or are you talking more so about implementation and its usage? Implementation side. Yep, no worries. So upcasting, downcasting, how do we go about using it? What was the project this semester, out of curiosity? What shadow was it? Barn wheel? Oh, Mario. Okay, so it was Shadow Mario. Okay. Oh, okay. I think that's an interesting one. And was there a requirement to go about using parent classes and subclasses? I'm assuming there was something along those lines. Yeah. Okay. Cool. All right. So we'll go, I guess this is, I think, a good level in terms of what we can go about covering in today's workshop. And also just other sort of extra things as well. Not only will be covering our list of topics, we'll also be covering these. And finally, the last hour, maybe even more than an hour, we're going to be trying focusing on more of a practical component. So we're going to be talking about through quite a lot of questions in terms of both. We'll give you guys, let's say 5-10 minutes to do each question, but then also more importantly, we're going to come back. Okay. We're going to discuss a little bit. How do we, maybe we can go about doing the question together as a group, and we can talk through the sort of the intended pattern or the intended usage of what the question was expecting from an answer there. Okay, cool. All right. And of course, we'll leave the last 15 minutes or so to go through general advice and everything. All right. Shall we get started? The very first topic for today would be the next slide, which is going to be coming up as generics. All right. So the first topic that we're going to be covering today is talking about generics. You can talk about from the name itself. We can just talk about its generics in terms of the English meaning. Generics meaning, I don't know, something generic, something that doesn't follow a particular or very specific use case. That's just this English meaning. But what does generics mean in terms of from a Java perspective? It follows a very similar use case in the sense that what if there are particular parameters or types within our program that are not defined at particular, I don't know, maybe, I don't know, you want to change it out and you want to replace it depending on what you want to use. This is something that's particularly useful in languages that are bound to types. You may be familiar with other languages such as maybe, I don't know, JavaScript. I'm going to just name it off the top of my head, where that you are not bound necessarily to a particular type for a variable. You can go about defining a variable without necessarily defining its type. Okay, so maybe in the first line, you could define it as a number or an integer, but then the very next line, you could go about changing it straight away to like a string or a list of some kind, and there will be no repercussions for it at all. This is, I guess, on the opposite end of things, we can talk about from the concept of Java, where that things and variables are bound to a specific class or type. And as a result, we run into issues potentially where that what if we want to maybe change the different types that we have? I guess one of the best examples that we can go about using generics would be our data structures that we have in Java. You can think of things such as the array list, hash map, linked list. I mean, the list can go on in a sense that you can go about replacing within a list any class that you'd like. Can I have a list of integers? Sure. Can I have a list of strings? Sure. You are not defined to a particular type. And whenever you want to go about using that data structure, that is when you can go about changing the class itself. Trick question to the audience. If I define my list as list and I define my generic as string, can I go about having different types within that list? Can I add in, I guess, I don't know, an integer into that list? Yes or no? You don't have to raise your hand. You can just shake your head or nod your head if you believe which one you can do. I'm getting a few shakes in there, and you are correct in the sense that when we go about defining generic, let's say we create an array list of strings, you're defined and limited to that array list to be having variable types of string. That is one small limitation in terms of what actually we can go about using generics for. Once you have defined that generic as a particular variable or type, you are bound to that type. When you are programming everything up and typing everything up, before you can even run the program, it will complain saying that, hey, you can't add integer into this list of strings. Okay, so this is what it's sort of talking about when the type can be bounded. Okay, so we can now go about saying that sometime we can just say the letter T, which is the generic itself, to say T can be anything. I can put in the list, I can put in the string, just like in the cases of array lists. We're not defining it or bounding it to any particular type. We can also, let's say that I want to restrict my array list for whatever reason, I don't know why, to only numbers. I can go about saying within my definition of the class to say that, hey, the type can be bounded and say T extends number. What does it mean when I say T extends number? It is saying that I can only go about having classes that are subclasses of the class number within this array list that I'm using, or in the case of generics. So in this particular case, I can go about in my array list, can I go about adding integers inside this array list that I've created that has t extends number within it? You can nod your head or shake your head. Yep, nodding your head. Can I adding in floats as another examples? Doubles, strings? No. Okay, so you are limited to those classes that go about implementing or extending the particular number or comparable interface that we go on. Cool. That's anything you want to add to that?
One thing. So Charlie touched on it before, but it's an example here. So this T, does it mean anything? Like if I have an S here, is that a difference or does it have to be a T? What does everyone think? Maybe shout out. It can be different, yeah. So I just quickly wanted to add, so when it comes to generics, we just pick a capital letter, right? And then there's a bit of a convention. So you'll see like STU being used, but it doesn't have to be. So if it says a T or it says a U or it says an S, it just means you picked that letter to represent this generic object. And then this means exactly the same thing, right? Like U is just a number we like, extends comparable, and then T is another generic. So what it means is that this U and this T are two different things. What they are is undefined. Well, not undefined, but you define it when you implement it. Does that make sense to everyone? Yeah? Okay, that's all I had.
Thanks, Rob. Which kind of brings up my whole point in terms of generics, is that when we're using this, we are using letters, generally, most of the case. But does anyone know something that is somewhat related to this, somewhat related to generics, that we don't use letters for? I'll give you a clue. It's a symbol. And you're asking me this. When you ask something, when you ask a question, what's that symbol that follows? The question mark. And what does the question mark mean in terms of the case, in its use case of generics? It is called what we call a wildcard. It is used in that case where that, let's say, you can look this up. I guess you guys can find your own definitions of it, but I'll try my best to try and explain what a wildcard is within the concept of Java. I just mentioned before that if I were to say, define array lists, I don't know, of T, and that T I can define as string. When I create that array list of strings, I can only put in strings inside of it. But what if in the future, I don't know, I want to put, I don't know, variable different types, okay? What if this array list wants to be of type strings, but another array list wants to be types of integers or whatever? This is where we put in what we call the wildcard. It is simply a placeholder, okay? A placeholder generic that is used until you actually know what needs to be put in there, okay? We'll go through maybe an example later on today, but I just want to highlight that in the case of future questions, okay?
I think, are we done with generics? I was going to say, I actually think maybe the next thing we should touch on is inheritance, because then if you're not super clear on inheritance, this kind of language of T extends number might be a little bit confusing. So maybe I can suggest we quickly talk about inheritance and what that is like in object-oriented programming, which Java is, and then this should make a lot more sense. Okay, so yeah, perfect. Let's maybe, okay, do you have an example you want to talk about? Yeah.
Okay. So I guess I really want to quickly go through, I guess, in terms of inheritance from a concept first. We'll go through implementation just yet. But as a concept, it's really important that, I guess, the difference between inheritance and both implementation or interfaces. Okay. I'm sure you guys probably have heard the terms ISSA or what's the other one? Can do or something. I forgot the exact words or what point it is. But the point is that when you're following an inheritance pattern, it is trying to follow the fact that these two objects are of each other. Okay, so a bird is an example of an animal, for example. Okay, and a dog is the example of an animal. Those are all conceptual relations between, I guess, in a parent class and a child class. We can sort of contrast that with the use of interfaces, where that's not the same relation anymore. It is more so when we're comparing interfaces, we're more so comparing, I guess, similar abilities that each particular thing can do. So let's say that we want to have, I don't know, let's say some common example within programming is that you want to be able to print it to some particular thing. I don't know. Okay, that's probably a bad example. But anyways, If a particular class goes about implementing this printable interface, do you expect it to be printable? As in it has the functionality of printable? Yes, because that is the whole point of defining that interface. Any class or object or subclass, whatever, that goes about implementing this specific interface, you expect to have some particular functionality related to printable. There will be a method that is defined within it. So let's say prints, okay, and any class that goes about implementing it would then have that functionality to find within it, okay? So this comes back to talking about inheritance. When we're using inheritance, there is the concept of parent and child classes, okay? When we have a parent class, you can define that as both either concrete or abstract. Those concepts are a little bit important because that then influences our implementation as well, okay? You can kind of guess from the name of the word abstract, meaning that if you have an abstract parent class, can you use its constructor? You can shake your head or nod your head in terms of whether you believe it can be used or not. So can an abstract class use its constructor? So let's say in this particular example, an animal is an abstract class. Let's just define it as is. Can I call the animal constructor? No. Most of the cases, okay? Because there is one tricky thing as part of this. Let's say that I inherit from this another class called bird. And then within the bird's constructor, I don't know, let's say I take in a name for the bird. In this specific context, can I call the animal abstract classes constructor from this specific context? Yes or no? Nodding your head or no? Got a small yes. Yes. Okay. This is the only context in which you can go about calling and instantiating the animal parent class. Generally, you wouldn't call it animal, okay, from this particular class. You would generally use the keyword super. These two mean the exact same thing, okay? Super is just referencing the parent class, okay? You'll probably hear it being used in terms of referencing the parent class's attributes, the parent class's methods, okay? You can also call its constructor in its exact same way as well. Okay, so that's one key thing to note in terms of when you're going about using parent classes or specifically parent abstract classes versus its child class or subclasses in that particular case. Okay, all right. Anything you want to add, Robert?
Okay, so I think if I can just extend Charlie's example, there's probably two things I wanted to touch on here. Maybe the first one is we'll talk about inheritance and sort of what that looks like, and then maybe talk through an example of an interface. So could we clear the board? Oh yeah. Okay, and you can kind of imagine inheritance a bit like a tree, right? I have something that is a parent, which is going to be an upper node of the tree, and then that goes on and on and on. So does anyone know what the very top node of this tree will be in Java? Have you covered this? Let's tell me now. Okay, so object, yeah. I just quickly wanted to point it out, right? Like when you think about inheritance, you can think about a tree and there's a top thing and then there's going to be something else and then something else. And in the example that Charlie had, we'll call animal as in the top thing that you provide. So you create like this class called animal, and then you can have is a relationship. So then you could have a class here called bird, and then maybe a class here called dog. And there's no limit on how many nodes this tree can have, but you can just have all of this. And so why we go on about this in so much, in Java, there's this top root node, which you'll see something called an object, right? And like if you don't know it, it's fine. But just bear in mind that this tree structure is very inherent to the language. And so we spend a lot of time doing object-oriented programming. You can kind of imagine with the link here, but there's just this notion of trees. And what it means, everything down the tree has to implement what's defined above. So if an animal has a method on it, let's call speak, right? And this does something, right? Then your bird and your dog will have that method. And that's what we mean, right? So I come down here, the dog will have to have speak because it inherits from animal, and the bird will have to have speak for the same reason. Everyone with me so far? So maybe we won't go into syntax, but what it actually does in here, you can define to be slightly different to the parent. But why I introduce this is because I want to talk about upcasting and downcasting, right? So if I create a bird, I have a bird, let's say it has a method called speak, and it has another method called tweet, and then it's got a method called fly, right? So it can do three things, and I create my bird, and then suddenly I want to upcast it. Everyone with me with inheritance and upcasting, what does that mean? Can someone tell me what that means? So upcasting is I go up the tree and I treat it as the thing above. So in this particular example, what's above the tree in bird? Animal, exactly. So then I start treating my bird like an animal. And when I do that, right, so if I encode, start calling it animal, what does that mean, right? It means that this animal refers to my upcast animal and what methods are available in my upcast. Just one, right? Speak. So when I call an animal and I upcast it, I can only use the methods associated with the parent. I can't use the method associated with the child. Is that a little bit confusing or that's, yeah? Okay, so I say that because you can kind of go up and down this tree, and what it means is you're not creating a new object, right? I'm not creating a new animal. I'm just treating bird as an animal, and then whatever methods are associated with that animal, I can use. But I can't call it like tweet because it'll say, it's an animal. It doesn't have a method called tweet, right? Yeah?
If we were to use upcast the bird object and we call the speak method, which speak method?
Oh, that sounds like an exam question to me, Charlie. What does everyone think? So let's just say I have two, right? Like let's give implementations. So this one we'll call print, and it says, what sound does an animal make? Run. I don't know, like, okay, I'm not very creative, but this one, let's say we'll define speak, and it'll call tweet, and then tweet. Hang on, I'll step prints. Okay, so Charlie's question stands. I encode create a bird, but I call it an animal. Do you want me to write that out, or is everyone with me? Yeah? I'll write it out. Okay, so I go, what do we call bird? Testing my Java knowledge here. var. Do you know Java, Charlie? Do you want to? I program in Kotlin, so it's been a while since Java, but
Oh, wait, I just got bird.
yeah, a bird is an animal.
Bird is an animal?
Yeah, is equal to animal. It's the other way around, isn't it?
Yeah, it is.
Okay, and then b dot print. B dot speak. All right, we got there eventually. Sorry, excuse me. But this is what it would look like. So everyone can kind of see what's going on here. I'm declaring it as type animal. So I'm saying B is type animal, which means I'm up the tree and it's here, but I'm actually implementing a bird. So what I implement or what I have is down the bottom. Now I call b.speak. What's going to be printed? And there's two methods here. One says run, one says something else. But what if I print is going to be printed on the command line? Anyone have a guess? Yeah, perfect. Do you want to walk me through the logic there? Yeah, perfect. That's exactly right. So what we're saying is when you implement an animal, you've got the method available at its parent, which in this case is speak. But when I call b.speak, it's a type bird. So what it actually does is it comes and looks at bird and it says this speak implementation. This speak implementation calls another method called tweet, and that tweet then prints tweet. So what we're actually going to be printing out is tweet and not run. Yeah? Everyone with me there? Okay, and then Charlie had a really good question here. What happens if I do this? B.fly. What's going to happen? Error. Yeah, do you want to quickly say why? Perfect. So what the answer was there is it's going to result in an error, which is correct. And the reason why is because we're treating it as type animal. Yeah. So when I have a type animal, the only methods available to me are whatever the animal has defined. And so in this case, b.fly, it'll just say it doesn't exist. Type animal does not have a fly method. Okay. So this would be an example of upcasting. So you treat it as a parent, and you can kind of see why this would be useful, right? Like in this example of generics, I have an array list, and maybe I need an array list of animals and I need them all to talk. You know, like I'm building a virtual zoo. And so then you'd want an array list of animals, but what the actual list could be was a mixture of different animals that you have. But the only thing you could do with it is you can just get it to speak. You can't get the actual animal to do anything else. Okay, so now a good intro into downcasting. How do we get this method to work? B.fly. What do I need to do to get myself out of a little pickle where I can't run this method? This was covered, right? Yeah, okay. Also, just full disclosure, this is the trickier side that we're talking about. So don't feel bad. We're just throwing the curlies at you.
So again, just as a hint, okay, when we go about using, I guess, methods from a particular variable, the methods and attributes that are available to use from that particular variable, so from here, B, are defined by whatever that type is. So in this particular case, we've defined bird as type animal. What methods do I have available in animal? We only have, as far as we know, speak. But what is the type or class that does have that fly method? Bird.
Yeah, no, that's exactly it. So I think then the question becomes, how do we go from animal as a type for this B to a bird as a type for this B? Because if this was a type bird, like maybe we can quickly write that out. But if I went bird B equal to new bird, right? And then I called b.fly, would this work or would this not work? So ignoring this one, I've done this. Is b.fly valid? It is, right? Because bird is defined, has a fly method. So now I've actually done this, right? So I'm sitting here, but I want to be here. Is there a way you can make this change? Yeah? Yeah, perfect. So what does that look like, right? And the answer is downcasting, exactly why we're talking about it. I need to convert, and I tell Java, no, actually, I'm very confident that my B is of type bird, not of type animal, right? And when I do that, I downcast, which means I force it to be a specific class. And it looks exactly like this, right? So this is a bit syntactical, but essentially what you're saying is that my B2 is actually the bird of B, right? So it's the same object. We haven't made any changes, but we just tell Java, no, it's a bird, it's not an animal. And then Java will go, oh yeah, okay, that's fine. Now you can tweet or fly or do whatever you need to do. Yeah? Confused faces, but yeah. Yeah, perfect. So that's another implementation, right? Like what happens here if I force my B2, instead of a bird, I also have a dog, right? So if I go, my bird is of type dog, and then this also has to change to be dog, what happens here? It's
essentially, it's not even downcast. I don't care. It's just casting.
so yeah, and I think what we're trying to show here, it's invalid, right? Like I'm on my tree, I'm here, and I treat it as type animal. I try to jump across to something else, and this should result in an error, right? It's not allowed. It doesn't make sense. And so then we need some sort of protection, and there's some keywords in Java that offer you that protection, and it's called instance of. Maybe is everyone with us on this? Can we rub it out? Are we blowing some minds? Yeah. Yeah, so great question. And this, I think, benefits of downcasting. So does it make sense why we would want to treat like having a list of animals and then why we would want to go down the chain? And this actually you will learn more about next year in software modeling and design, but you can do it. Whether you should do it or not is a different question. So what you should sort of learn there is when you do this downcasting, it's what we call like a bit of a code smell, right? It means that you're treating your variables a little bit weird, like it's not a very common thing, and it's usually an indication that something else or there's a better way to do it. And so downcasting is possible. Whether you use this in industry, the answer is you don't. It's a code smell, but you can do it. So we're learning about it, so you understand you can go up and down the tree. Whether you go down the tree is a different question. Does that answer it? Yeah. Okay.
Someone correct me if I'm wrong on this, but should look something this.
Yeah, this.
I think it's like class or something, like something along those lines. Like that definition there. Someone correct me if I'm wrong. I'm sure someone has intelligence out that's ready to correct me as soon as they can. But the point is that there's going to be some instance of method where you will compare it against some particular class name, okay, and then it will return true or false based off if it is that instance or not. And based off that answer, you can go about hopefully safely downcasting to the necessary class. That will be the safety check to prevent us going about copying across different classes that we potentially and may not or should not be doing. So maybe in that case, that example that we just went through, let's say that, I don't know, we accidentally went from a bird to a dog. This is the method or the check that we go about using to prevent us from doing that. But of course, you should ask yourself that question, whether or not you should be doing it.
Yeah, that's maybe next year's conversation. Okay, so does this all of everything we've said make sense so far? Are you happy for us to move on? Any questions around inheritance and upcasting, downcasting? No, okay. So just one last one to kind of close the loop here. We also learned about something called interfaces, right? And so we've talked about inheritance, right? And you can imagine we said that that was a tree and like an is-a relationship. So an animal, I can't spell, but animal and a dog. So a dog is an animal. Then let's talk about interfaces and what that means. So does anyone want to try give a definition, or do you want me to just talk? What are you feeling like? Okay, so there's really just one key difference here. And when I say an animal is a dog, what that means and what we've seen before is that I inherit all of the stuff the animal has, right? So if my animal has an internal variable called, I'm not very creative, but number of legs, right? Then a dog will have this variable called number of legs, right? And that just means that there's implementation detail there, right? So an is a relationship. Inheritance is very, very similar, but I think the terminology here is can do or something like that. And the idea being something again. So I have, let's say, printable as a type, and printable will have a .print method on it, right? It probably doesn't take anything, but you can imagine what print means. And then when I inherit, or like I not inherit, but I implement this printable interface. So then let's say a dog inherits this. What does it mean? It means that this dog has to have this method name on it. Yeah. So we have like a method name, but there's no implementation. Here we get implementation detail. So it's just two sides of a very similar coin. And you can kind of imagine there's scenarios where you really care about copying the implementation down, right? I only want one animal. It might have some methods. It might be an array list. And then I have another thing like a printable or comparable or any of these able statements where it doesn't necessarily make sense to have an implementation, but I definitely want a method that I can call that I know will definitely exist. Right, and that's essentially the difference. So interface, it's just skin or like skin and bones. There's no meat here. Inheritance, there's meat, right? And if I add more meat at the top, then everything downstream gets it. Interface, it's just a method that I know exists, and that's it. Okay, so anything to add?
I was about to ask a question to the general audience in this particular case. So we mentioned before that, I don't know, in the case of animals and when we're using inheritance, we can have a list of animals. Am I correct? Yeah. So inside that, let's say I create a list of animals and we can store different types of animal within that list. We can put in birds, we can put in dogs and add them all to the list and it will be completely happy. Can I then also have a list of printable things? Why not? Because the answer, I believe, is actually you can. Interfaces can actually be used in the exact same way as parent abstract classes. Okay, it's just that you can't go about creating a constructor for it because obviously it doesn't exist. But you can go about having a list of printable things, but you just need to make sure, let's say, I don't know, in this example, do we have this? So we have a dog that goes about implementing the printable interface. You can go about adding the dog class into that list of printable lists. Okay, so interfaces, I think that is where the powerful part of interfaces is that you can treat it just as like another data type. That's where it's actually going about to be powerful, to be used. It's not just another thing that you just go about adding towards the end of a particular class to say that, hey, this dog is printable, and you never see the interface ever again in your code base, okay? You can go about using the interface as a quote unquote data type, so you can use it in lists, in hash maps, or wherever you need to go about using it inside your code base. I think the best example would probably be to cover it within the bring into the context of maybe the Shadow Mario game. What's a common, I guess, feature all the different objects within your game have? Name one. Does it need to appear on the screen? So if it needs to appear on the screen, then you would probably define a draw method of some kind. One way of going about implementing that would maybe to have a drawable interface as an example. You might have gone down the route of having the draw method inside the parent class, which is also completely justified, okay? But you can just as easily also have a drawable interface as well. And then let's say within your main class somewhere, instead of iterating through, I guess, your list of, game objects, okay? You would iterate through a list of drawable interfaces, and you'd just be calling the draw method in each of those, okay? Everyone following along? Yep. Yep. Yes. Ooh, I'm not too sure within the primitive arrays, but definitely within the context of lists, at least. It has to implement the interface itself. Yes. Okay. Cool. I mean, that's exactly what we were talking about in terms of generics as well. You can add in anything you like. You can add in classes, anything you like, just not primitive types to it. Okay.
I think that's everything we want to say. Maybe just come back here to close the loop. So then this T extends number. We all understand what this means now, right? And in particular, this type T, if I was to draw this as a tree, what does it mean? It means, well, can someone first tell me, is number an interface or a parent class? Tricky question, but it doesn't matter, right? So I'd have this top thing called number, and something would implement number, which we know, like in the Java language, is a float or a double or anything like that, right? So what it means, I can now have this T extends number. It has to be anything that extends number, so anything downwards. Okay, and then this next one, U extends comparable of type T. What does that mean? So comparable, is this an interface or a parent class? An interface, right? And we kind of know it is because it has this able at the end, and that's just convention. So there's an interface, which again doesn't really exist, but it tells me that there's this method comparable, and I already know like the comparable interface implements like a method called .compare, which I think you've probably seen before, but it means that you can compare two objects. And so U extends comparable is exactly the same thing. There's a comparable interface here, and then something will implement it, something will implement it. And then the only tricky thing here is it's of two types, which we can talk about, but U extends comparable of a given type. And that means like the syntax just says that actually what implements comparable has to be able to compare. So if a string to a number maybe doesn't make sense, but using the syntax, I can enforce that this has to be of a similar type, so number or whatever. But a lot of information. Main point is we've got this inheritance and interfacing, and then we can use it in interesting ways.
One last question to the broader audience again would be, and when we're talking about the difference between inheritance and interfaces, I guess there is one specific thing that is, I guess, quite specific to Java, would be, can I inherit from multiple classes? So let's say I have a bird or a dog. This particular case, let's say that it inherits from animal. But let's say I want to make it inherit from pet as well. Is that possible within Java? No. Okay, so that is one, I guess, awesome rule within Java. It is such that you can only ever extend upon one class. Whereas this is in contrast to interfaces, I'll take a guess as to what written is. Can you implement or have, I guess, implement go about having different multiple? Yes. Okay, so that is something just to be aware of when you talk about using code. You can clearly see that inheritance, you kind of stuck to that structure of being like, okay, it's very much in that tree-like structure, but maybe there is a use case, maybe that you want some particular class from something else. You want it to have some other particular capability to have, and that is where the powerful use case of interfacing comes in. Yeah, the fact that, okay, even though my dog class already inherits from animal, I can make it go about implementing principal, movable, rollable, whatever. Okay.
Yeah, beautiful.
All right. I'll just quickly jump over. There's some other stuff here that we're going to be, I guess we'll skip over, I guess, but we'll just
Well, should we do a quick survey? I said before, so we've got 2 hours here, and we're keen to talk for the first hour and then do some questions for the second. The next bit of tricky content we thought we could talk about is exceptions. Is this something that people want to talk about, or we can briefly, yeah, okay, there's a lot of nods. So let's talk about exceptions. Okay, do you want to, yeah, let's maybe time box this to 5 minutes.
Wait, sorry, okay. As another on top of that, we prefer to talk about exceptions or design.
Well, let's do 5 minutes of exceptions, and then we can do design patterns. Okay, so I think here, right, a really nice intro. We've just talked about inheritance, so I'm going to scratch that off. But there's 2 different kinds of exceptions that I see, right? So let's draw a little tree, and this will really link in versus the check versus unchecked. So I have this parent class that I call an exception. Does anyone know what my 2 children are? So this is Java specific, right? So when I have exceptions in Java, it's sort of on the board there, but 2 things can happen, right? First one, I run my code and then I get an exception during runtime, which someone could probably have a guess what it's called. Runtime exception. Yeah, boom. And then, yeah, compile time. Let's just call it compile time or exception or something. I forgot this. Anyway, so this name I've forgotten, but it's exactly the same idea. So I have this generic parent class called exception, which might be an interface. Implementation is not super important. But what happens is that during my compilation, things can go wrong and my code breaks, or during runtime, things can go wrong. And they both are treated very similarly. Like they're an exception that gets thrown around, but what happens with them is 2 different things. So this is probably where the checked and unchecked comes in, and we just quickly touch on that. So runtime exception happens during my actual running of the code. So maybe someone gives me an input, like let's say I have a number and I have this. So I, let's say, have a divide function, which takes in num1, num2, and then I go return num1 over num2. And then what happens if I call divide with 1 and 0? Right, what's going to happen here? sake of time, we can talk along, but I call this function at runtime, I pass in a number 0, right? When I compile my code, there's nothing wrong with this. You know, like the Java compiler will go, oh yeah, that's a valid divide operation, syntax is correct, everything's fine, it passes. But then when I run, I put in a 0, 0 will come in here, and then I have a division by 0 error, right? And this division by 0 error is going to be exactly a runtime exception. I forget what it's called, but it'll have a name, division by 0, something like that. And so then this will get thrown when you run your code. And that's what we call a runtime exception. So it's something where syntactically your code is correct, and when you look at it, everything's fine, but then you actually have like an input that causes an error, and this error is going to be a runtime exception that will essentially get thrown and break your code if it's unhandled. Okay, so checked exceptions we've kind of talked about before. If I had malformed syntax, so let's say I had a backslash the wrong way around here, then when I try and compile this, the compiler will go, oh, that backslash is meaningless, doesn't make sense, and it will throw the exception during compile time, which will stop your code from compilation, right? So that's like a syntax error, but a runtime error is probably a lot harder to see. You know, it's not necessarily always obvious that you might have a 0 that comes into this function that causes an error. And so there's ways to handle this and keep your program running. You know, and I think, conscious of time, but like one thing that you do, so we care about this because I write a Java application and I run it for 100 users. And then one user passes me a malformed input. I don't want my whole server crashing just because of that. So you kind of have this way to isolate your behavior, and maybe you say, okay, only this user's program fails, but the rest of things will keep going. And if you didn't have that, so if you had unchecked exceptions, it would just bubble up all the way to the main method and then kill your program. And I'm sure you've probably seen that. If you try and run this and pass in a 0, you'll see that happen. Okay.
Which kind of brings us on in terms of talking about how do we actually go about specifically handling exceptions within Java, and that is through, yes, try. So on the very, very next slide we talk about is exactly that, in terms of how do we go about handling exceptions, what happens, what should I do if an exception occurs. This is exactly these 3 keywords. Try essentially is saying that, okay, try and run this section of code. If any particular exception occurs within my block of code there, I will try and catch it. Okay, and then within that catch statement, it will try to catch for a specific type of exception, and then you can go about doing something with it. Okay, it's something really important to note there is that that catch statement is catching for a specific type of exception. It runs top down. Okay, you can have multiple catch statements, okay, and the first catch statement that that exception aligns with, it will cause that catch statement to run. So for example, let's say that I have where'd the marker go? Let's say that I have actually gone about 3 catch statements. The very first one, let's say, I'm going to put it as super generic and put it as the parent one called exception. And then maybe down here, I'm trying to catch another runtime exception down here. Okay, I'm not going to type that all out. But anyways, point is that if I have 2 of these in this specific order, if, I don't know, an IO exception occurs all the way up here, I catch it, which one of these catch statements then gets executed? First one or the second one? First one, okay? Why is it the first one? Okay, this really comes back to our sort of idea and to behind inheritance again. Why does IO exception match exception there? Okay, this is because the IO exception is a subclass, it's probably like all the way down here somewhere, okay, of the parent class exception. Okay, as long as that IO exception or whatever exception that gets caught within my try statement, okay, matches in some particular way with my, I don't know, exception that I've defined within the catch here, okay, it will execute that catch statement and ignore everything else that's beyond that. Okay, so that is why the order in which you define your catch statements is incredibly important. Make sure you put the most specific exceptions at the very top, and then as you go down, make them more generic. In other words, put the exceptions that you define that are further down the tree first, and then put your more generic ones, such as this one, the most generic of them all, at the very, very bottom, to try and catch everything else that you don't know that have been handled before. Okay? All right. lot of time. Let's just a final thing to mention about finally. That finally section of block always executes no matter what. Okay, even if an exception occurs, you can go about catching it, and then that finally section of block will still occur. Even if you're actually going about where do we have it? Okay, the only exception in which where we don't execute the finally block would be if we actually have a system.exit call within somewhere within my code. Okay, that is the only reason why, okay, a finally block would never execute. Otherwise, even if I put my return statement within there, okay, it will still go about going all the way to the end of my finally block. Okay, so those are the three examples I just wanted to highlight, as these are very interesting edge cases. Okay.
I think, is there any questions around exceptions here? Anything anyone wants to talk about? Oh yeah. So the syntax, right? So for a new exception, we exceptions are a little bit of an edge case. So I know before we've introduced this concept of classes, right? And so you can see we've actually talked about a class here that you instantiate, which makes sense. Top level class. The keywords here is we use throw to throw an exception, or inside Java, the same thing will happen. So in this divide by zero example, it'll throw an exception. And that's just a way of handling these error cases. So the only syntax that kind of exists is a try and catch to deal with exceptions. If you don't try and catch within your application, it'll bubble all the way top. If it's still not caught, it'll kill the program. And that's just how Java works. Does that answer your question? Yeah, correct. So we can, maybe let's have a look at what happens, right? So I execute this code top bottom. I'll come inside my try block, and then I will execute. So here, system.out.println try, that's going to execute, and then my code will keep going. Am I going to go inside this catch block? I'm not, because nothing inside my try raised an exception. So I skip this, but I will always go to finally. And so here you go system.out.println finally, and then that's it. So then you return, right? So next one is a very similar case. I go inside my try, I execute top down, I print try, but then I throw an exception. So what this will do is it throws an exception that'll bubble up. The thing that I've got wrapped around is a try statement. So it'll go in here, it's type exception. So these two match, or it like, doesn't matter if this was like a runtime exception, it would still match because of the hierarchy that we've had. So then it'll go inside my catch block. It will return, or it'll execute this line, which is print catch. It'll return, but then finally will always get executed. So here I'll print finally, and then I return finally. This one here is a very special example. Same thing again, execute top down, hit my try, hit an exception, go out, go to the catch block. But inside my catch block, I kill the system, right? This system.exit is like ripping the power cord from the back of your machine. It's just gone. And so then that's as far as you get, which is where we say try and catch. Whether you ever see this or use this, it exists. You can do it. You should never do it, right? Like, why would you rip the power cord out of your PC? Okay. All of that makes sense? Yeah? Let's go.
Rows, exceptions, yeah, exactly it. So when we're talking about, let's say, you define a method, let's say here, public static string test, at the very end of it says rows print. Okay? Why do we actually go about doing that? The reason why we have an saying rows exception, it is to tell the caller of that method, so let's say some other main test, to let them know that, hey, when you go about calling this method, my method, create, I can potentially throw an exception for you. I'm not gonna, there is no try catch statement within this test, okay? It's saying that, hey, you're calling it at your own risk, okay? And you'll potentially probably need to put it inside a try catch statement. Okay, so this is where I guess partially going into checked and unchecked, where oftentimes IntelliJ will probably remind you when you're calling a method that says throws runtime exception or throws IO exception, that hey, this method throws an exception, you should probably handle it. Okay? How do we go about handling it? It exactly is using surrounding our code by catch. Okay? Because if you, what happens if you don't use the try as Rob mentioned, that exception just keeps bubbling up. Okay, so if we throw an exception to this test method, bubble up to the main method, and then we'll just stop there. Okay, we'll make the whole program come to a halt because the program doesn't know what to do with that exception. Okay, that's why it's so important that we build robustness within our program with one of the ways, and with my tax standard, to know if this exception occurs, what should we go about doing to try and recover? Would it be raising the warning to the user to don't put in 0 as an input, or don't put in malformed input? The different approaches. Okay, cool. Any other questions? Otherwise,
let's maybe do 5. So is everyone okay for us to quickly cover design patterns for like the next 5 or 10 minutes, and then we'll quickly touch base on unit testing, and then we'll get started on the examples? Yeah. Okay. Awesome. So our maps and arrays, let's maybe skip that. We're happy to stay back and we can talk about this later. Maybe just know there's data structures that exist and they're useful for different reasons. We said before these data structures have methods on them. You can kind of see how that's enforced using inheritance or interfaces. Okay, so now we're on to design patterns. And I think maybe I'll talk for 2 minutes, Charlie, and then hand over. So first things first, design patterns are something that you'll see a lot, right? Like as you kind of continue your software journey forward, particularly next year when you do software modeling and design, you'll see more design patterns. Why they exist is there's very common problems. And maybe you've seen this when you sort of start coding, you try and create a game, and you're like, 100 people have created games before me, there's got to be a better way to do this, and you'd be right. And the answer is design patterns. So one thing to quickly call out, you learn about some ones here, you'll learn about some more, and then you kind of go through and use these design patterns. But I sort of like, we'll go over these in detail. One thing I quickly want to mention, I said before, design patterns are like a common or like an agreed way to solve a problem. But what that means is that a design pattern solves a problem, right? It's not a generic hammer, and when you've got a nail and you can always use the same design pattern for multiple problems. It's very much one design pattern solves one problem. And that is a common mistake we see all the time. You start learning these things and then you just think, oh, I can use singleton everywhere. Well, actually, singleton solves a specific problem. You use it when you have that problem. Does that make sense to everyone? Yeah, okay, perfect. So let's quickly go into the details of these. First one we'll touch on is singleton. And if I haven't said before, singleton solves a problem. If you don't have this problem, you don't use this design pattern. And that's like a very good way to know which one to use. Some of them do get a little bit murky, but the ones that we're learning about, I think, are fairly clear. Okay, so the singleton problem, does everyone understand what this is saying? And then I'll quickly talk about why. So as the name suggests, singleton, I only ever have one instantiated class. Why would I only ever have one class in a system? Probably because I have a physical resource. Like the Java virtual machine, you've got one set of memory on your actual laptop, right? And so if I'm modeling the physical memory on my laptop, I only ever want one. I don't want to accidentally have two and then have the same program or the same thing pointing to the same memory. And so if it makes sense for you to enforce only having one, the singleton is that solution. Maybe I have like a printer and one physical printer on my network, so I only want one printer or whatever the case is. But if you've got this problem, then you use the solution. And what the solution looks like is a little bit of syntax here, but you can see we've got a class, right? And you can see inside the class, there's an instance of the class itself. Does that make sense to everyone? A little bit weird, but then what's important to notice is this minus sign means it's private, right? So I can't just go and get this instant, I have to call it. And what I have here is this get instance thing. So this get instance returns a singleton. It's a static method, right? So I don't instantiate a class to call it, but it's attached to the class. And so when I call it, or this client will be calling capital S singleton.getInstance that will return an instance. And then the implementation of the method will just check if there's an instance that exists, I return it. Otherwise, I create one and then I return it. Right? And obviously, I update my variable just to make sure that I return the same thing every time. So it's a design pattern. It's got a very specific solution, which is this implementation level detail that we've shown you. And you use it when you have this problem. Any questions about singleton? No? Okay, awesome. So we'll go to the next one, which is factory. And factory gets a little bit more complicated. Let's go back to the animal example that I had, right? Let's say I have bird, I have dog, I maybe have a few more. Now, inside my code, can you imagine how messy it's going to be if I have to instantiate all of these classes in a line, right? Like I have a list of 150 animals for my zoo, and then suddenly I have new animal 1 is equal to new bird, animal 2 is equal to new dog, animal 3, and there's just 150 lines of code, right? Like, there's got to be a better way, and you'd be correct. There's the factory method. So the factory method, the problem that you've got is creation logic, right? And what I say by creation logic, we mean creating new instances. So in this particular example, it was, I have my zoo and I'm creating new animals. So this problem of complex creation logic, I use a factory. And the actual syntax maybe looks a little bit hairy, but remember, the core problem is I want like a designated spot to put my creation logic. And let's just imagine I have more complicated, so, animals and 2 implementations, whatever that looks like is not so important, but I would have a core implementation or like a factory, as you would imagine, that I go to get these creation logic. Are we all okay with what I've said so far? Okay, so I'm conscious you're probably not going to get queried about the implementation of a factory, which is why I was pausing. So I don't think we'll go into it, but you can kind of imagine you'll have a separate class that will have like a create method. You have a factory with its own internal logistics of maybe multiple animals. Maybe you do some complicated stuff, but when you call it, so whoever's using your factory will just get a very simple animal back. So you hide all of this creation logic away in a separate class. The implementation details look a little bit like that. I think I'm going to lose a few people if we go through that, and I don't think you'll be assessed. So are we okay to skip the implementation details? Yeah? Okay, awesome. Next one. So template method. This one here, I have a different kind of problem. And the problem that I have is maybe I am, what's a good one? So do you have an example of template? I have a car factory, right? Like ignore the word factory, but I'm a car manufacturer and I have different types of cars. Every single car I have always needs to attach 4 wheels. It always needs to attach a steering wheel, but it has different kinds of engines, And so when I drive these cars, it's all very similar for the most part, but there'll be differences. And so template is like a method or a design philosophy that helps you deal with this particular thing. So I have an algorithm that I'm trying to run. And then as I go through, some of these steps will be the same implementation detail. Some of them will differ. Rather than having, like logic everywhere, I just use this design pattern to solve that problem. And one really important thing is that the template uses inheritance, right? What does that mean? We talked about inheritance being the top class and I'm inheriting, but it is a relationship. So there is shared implementation detail, right? The same code is written for multiple child classes, but also some code won't be shared. So that's the key thing here. You're using inheritance, and that's because you get all of this actual implementation detail for free. Does that make sense? Or do you want me to try again? Yeah? Okay. So you can kind of imagine what that looks like. We also have this notion of abstract. So some of these steps just won't have implementations, and then some of them will. Okay. Shall we go to the next one? Okay. The next one's strategy. So before we talked about inheritance, and we said the shared functionality. So my car inherits the same method for bolting on the wheels. Strategy is a little bit different. I want to be able to do the same thing. How I do it is very different, right? And so there's no shared implementation, there's no shared code, but there is a shared method. And so that is going to be an interface, right? The actual implementation of the strategies could be very different, but what I do with them is the same. And a classic example here would be sorting. So I don't know if you guys have talked in maybe algorithms, the different sorting strategies, but like bubble sort or linear sort or whatever, all of those would be different strategies to sort and they have trade-offs, but what they do is they sort a list. And so that is a very good example of strategy where I just want to do something like execute my sort algorithm and then how I implement that could vary. And you kind of do that to just, like you'd start off with the most basic example. So maybe I just do linear sort, and then once it's working, then I swap it out for a different sorting algorithm. That's like a really good example of this. But the idea being it uses interfaces, right? There's no shared implementation detail, but the method signature is the same. Yeah? Okay. And then the last one is observer. So observer is probably a little bit more of the trickier ones. Implementation detail you can see is looking a bit hairy. Again, I don't think we'll go over implementation, but what you'll learn in the future is that there's this like notion of trying to keep things separate. And so observer is like just a clean contract between the two. So rather than having to know all of the information of a system, I just want to be notified when something happens. And so the observer pattern solves that particular problem of like getting notifications when an event happens, but it'll just bubble up and then you find out about it. And so I think when it comes to observer, implementation details can get very hairy. It's probably the hairiest one that you've seen. The core problem that it's solving is about this independent observation of events. And you kind of see this all over the place. So I don't know if anyone's done any like web programming or like a user interface when you click a button and then there's a notification that you've clicked this button. Exactly the same kind of principle, right? So you don't really care about how that button was clicked or where it was clicked, or even if it was a button, you just want to know that the button's been clicked. So that's the observer pattern. So it's very common. That's why you're learning about it. A little bit trickier on implementation. Do you want me to go over that anymore, or does it make sense? Yeah? I think key takeaways for these design patterns, remember its problem that it's solving, have a good understanding of when you can identify this problem. And then if you see this problem, you already have the solution, right? That's exactly what it's for. You don't even have to think about if there's a better way. This is the best way, right? And that's why you're learning it. Okay, anything to add there?
Actually, no, sorry. I guess I'm talking about observer. I guess this kind of drives into, I guess, some of the more advanced concepts. I think I will mention later lectures. I think one of them was event-driven architecture, where we're in the observer design pattern, we are kind of trying to introduce you guys to that sort of hub sub type of nature, where that programs are no longer sort of entirely responsible for looking at a particular stack. I guess one of the sort of like abstract examples that I like to give is that, I don't know, when you guys are on your phone, you guys get notifications, right? You're not entirely responsible to keep on scrolling through and refreshing your Facebook feed to check if someone has actually posted a new photo or a new post or anything. You get notifications based off that. You are decoupling that sort of logic of checking everything, okay, instead moving towards what we call a pub sub model, where that instead it is up to the individual sort of interested parties where that they can go about subscribing to interested things that they want to know. Okay, maybe I am interested to know when that door opens, when a new participant rolls in, so I can mark a name off for a class. Maybe you're interested in knowing when Tesla prices will be going down in the future. I don't know. I'm just naming some random examples here, but it's just a different time going about understanding programming itself. Okay.
Yeah.
All right, I'm being wary of time. We've gone a little bit over time in terms of where we wanted to be, but hopefully that's okay. I hope you guys are learning something through these. Okay, but what we're going to try and do now is going to give you guys a quick sort of like 5-minute breather. Okay, I understand that we've been talking for the last an hour and 15. There's a lot of content to go through. So we're going to give you guys a quick 5 minutes. Get yourself together, go for a quick walk, stand up, doesn't matter. Okay, and then we'll come back. Okay, and we spend the last hour or so to go through. Okay, so there's 3 questions that we'll be going through in just a second. Okay, well. Back together around 2:20. Okay, and then get started. Cool.
Thank you.
Thank you.
Yeah. Always on.
Yeah, I did access. I did update the last few slides.
Oh, the last few slides, was it?
Yeah, the last few slides for QR code and
That's so it's, ooh, what did I click? So this one?
I should have updated everything back here.
Yeah. Okay. Cool.
Yeah. Do we, yes, I don't remember what these questions are. So you should.
First one was the shopping. So should we click into it? Yeah.
And I just maybe we should show it on
Yeah.
the big screen so we can talk about it.
Yeah. If I sent a email to your manager,
Yeah.
if you want to join.
我不中了。
Oh, yeah. Sure.
I have the code on mine. Yeah.
I'll let's talk about it as well.
First one is actually a pretty good one to talk about. It's the test case one, so we should be good.
Hey,
Maybe check that or share it. It's also right.
Oh, your screen sharing is paused.
no, I don't have any Wi-Fi.
I've got a hotspot.
Oh, like, as long as we can just spread them online.
Yeah.
That's how you go with sharing that.
Yep.
There
Yeah, test
might
it.
be
You can
some
test it out.
funkiness with. We can
I'll test this now.
Yeah.
Yep. There we go.
Oh, yeah, that's good.
Yep. All right, I'm gonna stop share.
Okay.
Because I don't have the slides up.
Yeah.
Yeah.
I don't think I'm able to have two screens up at the same time without restarting the meeting. Is it possible that you could have a split screen between the IDE and?
Yes. And
Let them go.
Sounds good.
Are you okay to code?
I'm happy to go. Yeah. Should be good. I mean, worst comes to worst, we can always just crowdsource, reference the solution they have there as well. Like, we got fallbacks.
It's probably not another one people that are.
I'll be back.
The actual code.
I don't think it's too bad. Yes, sir. All right, shall we bring back everyone? I'm just being wary of some people not being back yet. So for those of you that do know that there's someone next to you that's not back yet, okay, could you guys please take a photo of the QR code for them? Okay, so this hopefully everyone has already taken a quick look at the QR code here. Essentially, this QR code should lead you to a Google Drive that you have both the question and the solution to them. For your own sake, best not to look at the solutions just yet. Okay, but what we'll be doing first is we'll spend a quick walkthrough in terms of the first question, give you guys 5 minutes to go about attempting it, reading through the question, trying to understand what to ask of the question, and we'll quickly come back at around 2:25, actually 2:30-ish. Okay, 5 minutes time, okay, to go through the questions together. Okay, so, okay, hopefully everyone please go about looking at the first question for me. It should be a question on sort of like creating classes, what methods should I have, what attributes should I have, okay, and we'll come back together, okay, together to talk about where we should go about putting those methods, how should we go about looking at this question, and I don't know, maybe talk about unit tests as well. Okay, cool. So we'll come back, okay, in about 5 minutes time. Okay, we'll talk through those solutions together. Okay, so please go about trying to attempt the first question, question 1 for me. Okay, and we'll come in. Thanks, folks. Oh, is it like right now? Yeah.
Yeah. And then when the methods go.
Yeah. Yeah, that was honestly better than.
Yeah. The test cases.
Like examinable, like written textual test cases that I don't care about.
Yeah.
Implementation. And we can maybe quickly get like.
Yeah, I think that. And maybe whiteboards. Let's try to see that. Anything good?
Okay. This is my first.
Oh yeah, actually, maybe just Slack with video thing. It's a big nice moment, Charlie. You'll be going past the moment. I actually put up Marco featured as well. I'm gonna have to write that out. Yeah, I saw Marco's at Cranbrook now. Yes. Yeah. In Sydney.
Oh my God. It actually.
Is it working? Yeah. Okay. So how are we all going? Do you want to come together and talk about what you do for this question, or are we happy to take a bit more time? Give us any preferences? Come together? I mean, the class has really shrunk. I feel like we've lost half the people. So maybe we can just talk and then do this collaboratively. Okay, so has everyone had a chance to read this question through and everyone's clear what's being asked? Yeah, so I might just quickly jump to what's being asked. So we'll go over this text in a minute, but we're asked to write Java skeleton code, right? And just to be absolutely clear, skeleton code is not asking for any implementation detail, right? Like we want method signatures. What actually happens inside the methods, don't mind. We can just put a to do, skip over it. But we do need the methods, the classes, the syntax has to be all correct, right? So we're going to go for that level of detail. And then part B is 2 test cases for the above system. And they've given a bit of an example of a test case. So this one has got no coding. It's really just a description, input and output. And we'll talk about test cases and maybe what you should think about, and then edge cases as well. So, you know, just to maybe get your thoughts flowing there, that divide by 0 example we had previously, that would be an edge case, right? You kind of have to think about these kinds of things. And so when we're talking about test cases, what happens when I do something that's maybe a bit silly, but is definitely possible? And in my experience, you can't assume just because it's silly, no one's going to do it. It's probably guaranteed to happen. Okay, so let's talk about this. We need some skeleton code, and we've been given a question. So part 1 of the question is there's a store with 3 types of employees. You know, they do different things. Each employee has some information, like a phone number, an address, and then an employee is able to clock in and clock out. Then we've got some more information for a cashier, right? Does some stuff, does some more stuff, and then a manager has a unique password. So I'm skipping in high level detail, but what I really want to get out of this is there's 3 types of employees, right? So we've got an employee, and then they do some different things. So can anyone tell me what this might look like in code? And maybe we can just draw a tree before we get started on the actual implementation detail. Is that all right, Charlie? Okay, so can maybe someone shout out, how should I represent this in Java? What would make the most sense? So we're looking for some skeleton code. Before we get to coding, what is this? Any ideas? I'm trying to be collaborative, so feel free to tell me we're doing a bad job, but what do we have? Is this ISSA or can-do a relationship? Remember those 2? Let's start there. ISSA, yeah, perfect. So an employee is a cashier, is a stockist, or is a manager. So what does that imply? Yeah, perfect. So we're going to have this like kind of tree structure where we've got an employee, and then the employee can be of different types, right? And so type 1 is going to be a cashier. Type 2 will be a stockist. And then type 3 will be a manager. right? So you can kind of see we've already got this hierarchy, and we know it's an is a relationship because there's shared information, and in particular, shared what we're going to call variables, right? So can someone shout out what variable goes where? Let's have a look at this line. Each employee has a 6-digit employee number. What is that going to be? Yeah, perfect. So employee is going to have a variable and it'll be private because we do things properly. Or will it be, wait, maybe not private because then you can't inherit it. Anyway, so it'll have a variable called employee number. What's a suitable type here? 6 digits. Yeah, like I actually think it's not specified, so we can assume string or a number. Let's take string. And then I don't think we need any more detail, right? So I know you could probably do like a char array of 6. A little bit overkill, don't need it. We'll just have string. One important thing is we need getters and setters, right? All of these kind of things have getters and setters. Inside my getter or inside my setter, I can add this logic to make sure it's only 6. So we're not going to enforce it at this variable level, but when I have like an implementation of set string, I can enforce the string only has 6 numbers or 6 variables. So we're not asking for that level. We're just asking for skeleton code. So I'll have to have a getter and a setter in my code, please, Charlie. Get employee number, set employee number. And they're going to have to be public. Yep. Yeah, list the thing strict. I think one thing, so they have to be a 6-digit number. So we're going to have to check that. But yeah, like anything that meets this requirement will be fine. So I'm conscious we probably didn't give enough detail for you. In the exam, it'll be a 6-digit integer. That's it, you know, and so then maybe that 6 digits will have a range, like as in, yeah, but anything's fine. So implementation detail, we're skipping over, but we know that there's a private variable and then there's a getter and a setter. Yep. Okay, what's next? The system stores their name, address, and phone number. Where does this go? Employee as well. Yeah. I'm really making Charlie write out, but we're going to have another list of private. So name, what's a suitable type for name? String, does that make sense? Address, string as well, or like a separate class called address, but we don't need to worry about that. And then phone number, I think we can just do string and skip over those details. But the important is that they'll be there and then there'll be getters and setters. Maybe we can just skip writing the getters and setters if we're all okay to know that they exist, just to save Charlie some writing. Okay, perfect. So we've ticked up all of the first bit, and the important bit is that they're inside employee. Now let's get to cashier, right? What's going to be important about cashier? They're able to check out, which takes a list of items and produces the total cost. What does that look like? Maybe we can come up with a message signature.
Is there any particular shared behavior that all employees can do? I don't know, maybe let's say you guys and those start a shift and then end the shift. How do you guys go about knowing that? That will be, I guess, defining the clock in and clock out that shift. So I don't know, you could potentially have inside the top level, inside the parent class of employee as well, having those clock in and clock out methods. Okay. In terms of what you actually expect from the method signature there, it is kind of arbitrary. They don't really say what you're putting in at the time. Maybe you could put in clock in and the time, maybe, okay, but it's up to you in terms of arbitrary decision, in terms of what you define as the method signature, as long as it makes sense. Okay. So additionally, there will be also a public.
Oh yeah, I definitely missed that. That's my bad. So there's 2 more methods on employee. Okay, all good there? Yeah. So now let's go cashier is able to check out. What's this method signature? Can someone maybe shout it out? So cashier as a class is going to have a method. It'll need to be public because it's publicly accessible. What is its return type going to be? Produces a total cost. So total cost is probably going to be a double with a capital D. And then it'll have a name. And then what does it take in? So this is going to be a list of items. Yeah, so we'll just put list of type item. And we'll call this items, right? That makes sense. Implementation details we're skipping over, but it will exist. And then what else do we need? Okay, well, we had it. Okay, that's readable. So we're taking a list of type item and we're returning of items, we return a double. Okay, and then I think maybe for time we can just talk about the rest. And then if anyone has any questions, we can talk. But then the next thing that we need, so stockist is able to check stock an aisle and is able to check if an aisle needs stocking, right? So that's two separate methods. Stock aisle, check if aisle needs stocking, just some suitable names, suitable method structures, not really specified. So anything that you come up with that makes sense is fine. And then finally, we've got a manager has a unique password and is able to approve a refund. So a unique password, that's going to be a private attribute for manager only, right? So there'll be a new private attribute called password, and then they'll be able to approve a refund. So another method there. Okay, and then finally, when a new employee is hired, the employee is added to the system. So one thing that we're missing here that we don't have is the class that controls all of this, which is probably, we'll just call it system. You know, and so there's one class here, system, that internally will have a list of employees, right? Because these employees belong somewhere, and then some stuff will happen there, right? So employees added to the system. So then there's a list of employees and there's an add employee, remove employee. Does that make sense to everyone? Yeah? Okay. And then there's also a store, which maybe could be the system or is separate. But let's just call it store. Perfect. So then we've got a store. It's got a list of employees, and then it'll also have a list of aisles and that other piece of information there. And then there'll also be finally an item here. Okay. And then there's one more called item. And I think this describes our system. So I think what's just to quickly call out, like we're only asking for method signatures. So you should be able to look at this text and pull out that I need these classes, pull out what information is associated with each class, and then also where this stores. So like a store is probably this high level conceptual that just matches the generic information given. But if you can kind of look at the question and just construct something like this and then turn it into a very high level skeleton code, that would be exactly what we're after. Does that all make sense to everyone and how we got here? Yeah? Okay. And any questions around this, or are we sort of happy to move on to part B? No? Happy. Okay. So this part B about test cases, I think here, we're not asking you to code up anything, but we are telling you what we sort of expect it to look like. We really just need a very high level description, what the input would be and what the output would be. This description, input and output will make sense in whatever skeleton code you've created, right? So in this particular example, you know, maybe, okay, so ensure an employee cannot be created without an employee card. So if I create an employee without this constructor of, you know, like an employee card, then it throws an exception. The input is trying to construct it. The output is going to be that exception. What's some other maybe test cases that I can think about here? So we're just after two, right? And it doesn't really matter what they are. They just have to be valid in context. Is this beneficial? I can skip over this as well if it's maybe a bit too easy, or we can talk. Yeah, okay. But does that make sense? So for this kind of test cases, all you have to do is just think about the system and what makes sense. So maybe I have like a new employee, I try and create an aisle, or I do an invalid action, like maybe the stockist tries to improve instead of a manager, and that might not work, because it doesn't make sense in code. So all that you need for this part B is just think of two things that the system does. And as long as they make sense, or if it's an edge case, that's all that you need to answer. So it's very high level, just trying to understand the flow of the system and what you've mocked out, and then what's a valid input.
All right, so this second question again, okay, so we're going to give you guys 5 minutes to go through this question, because this second question is a bit more hands-on than that first one. The first one was, I guess, a very light introduction to get you guys started, to get you guys, okay, get back into the feel of what Java is. This second one, a bit more involved. Okay, so again, I don't believe, let me just double check. Okay, no, actually, it does require you to implement the methods. Okay, so this is actually where some code implementation is going to be coming into play. Okay, so this is where you guys may need to come back to think about the things that we mentioned previously at the start of the workshop, thinking about generics, thinking about everything about Java, and maybe its data structures as well, to see and go about how do I actually go about implementing this specific question. Okay, so again, I'll give you guys 5 minutes to go through this, and we'll come back at 2:45 to talk through the actual implementation, and we'll actually go through it together, hopefully in code as well.
Oh, that, sorry.
Yeah. That's what you got, Charlie. Yeah. To read the question.
Okay, everyone ready to talk about this question? So I think maybe to speed things along, what we've got here is just the actual implementation. So this is IntelliJ, I think is what Charlie's using. We've got the question in text just above, and then we'll just go through and show you what the implementation looks like. And so I think maybe we can just do this one at a time. You guys could potentially call out what you think is suitable, but let's talk about part A, then we'll talk about part B. That sounds okay. Okay, so for part A, what do we need? Charlie's jumped the gun a little bit, so just ignore that. But we need to create a Java class called file. So we would have that syntax of Java class called file. And we all know those method signatures. Beautiful. And then it should store a string file name. So here, everyone kind of knows what we need. So string file name, is that going to be private or public? Let's just shout out. Probably private is a good guess, particularly because you're asked for getters and setters. So we'll make private string file name. And then we need contents, which can be on any given type. So what does that ask for? Yeah, I'm seeing some keys. Yep. What generics? Perfect. So we learned earlier about this thing called generics, and we actually have to implement this as generics. So any given type, we don't actually know the type. So what we're going to do is we're going to pull out one of these words, STU. I think Charlie likes the word T, so we'll pull that out. And we go private, capital T, contents. So this T just means it's any given type. But you can see here it's red because it doesn't quite make sense. And it doesn't make sense yet because we haven't implemented file as a generic type. And so there's a little bit of square bracket syntax here where we then have to call the same letter of type T, and then we see everything goes green. So this is specifying file of a given type, but what this T represents is this thing in contents. Does that make sense to everyone? And it makes sense how we got there? Yeah. So can you maybe, Charlie, just to solidify this, create a file type of string and then a file type of double and just show me in a separate. Okay, so I just quickly want to touch base on this. So this is what you would look like when you instantiate. It's complaining because there's no constructor. But when we use it, we specify. Okay, so we're doing a little bit of implementation, but when we use it, we specify a file of type string and a file of type double, right? And it makes sense that then when we pass in this T into the class, what it actually does is it sets this contents variable to this type, right? So hopefully that makes sense on the actual implementation detail file, but we have a specific thing. So we say this is string and we pass in string. So then this variable will be S or string, right? And one thing to just quickly talk about generics, it's pre-compile time. So it makes a little bit of like, we're just doing some syntactical hacks here, but when you compile it, it'll just create like a swap out the T for actual variable string. So it's pre-compile generics. It's not runtime compiling, if that makes sense. Okay, perfect. So it looks something like this. You know, I pass in contents or I pass in a type double, and that's perfectly valid. I have two of these that looks like this. Any questions around this? We're good? Okay, so what does the next one ask? So write a Java class called folder, where folder has many files. It should contain a hash map files, which store the file names as keys and the file objects as values. File contents can be of any type. Perfect. So as you can probably imagine, a new class called folder. And then what do we need in there? Hash map. So do you all remember what a hash map looks like? So let's quickly create one. So hash map, you can probably take a bit of a guess. If you ever get stuck in an exam and it says hash map, this Pascal case is a very good indication. Java is pretty predictable. So hash map, hash, capital H, capital M. This is called Pascal case. The actual name of this could be like when you have a class name, it'll be Pascal. When you have an implementation name, it'll always start with a lowercase. This is generics. If you don't know what it is, so it asks for a list, capital list. If it asks for a list array, guess what? Capital L, capital A. So you can kind of have a guess. You can imagine we're using generics here. So it needs a key value pair for hash map. And we actually told that the key value pair is going to be file names is the key. We know file names is going to be a string and the file object is values. So file object is going to be just a reference to this file. Perfect. And then this is going to complain because is this valid for file? Like we're using generics. And so it actually needs to know what type of file you've got. But what's kind of tricky here is it says any type of file. So here I don't have enough information to say file will be of type double or type string, which is what we showed before, but I need to do something else. And we learned generics has this wildcard implementation. Do you remember that, where we don't know what it is, but it could be anything? So the question is essentially asking you to come up with that, right? And so we say file of any given type. But the whole reason that this square bracket is here is because file, just flick back to it, please, Charlie, is a generic type. You know, I have to put something there, but what I put there, I don't know. And so when I actually use it, flick back to folder, I put a question mark. Does that make sense? Yeah? Okay. And then the next part is the file contents can still be of any type. Okay, we covered that. Write a method called add file. So this is going to have to be a public method. It's not going to return anything. We haven't asked for any thrown exceptions. Yep, and then it'll just take a file object name. What is this? Named input and adds it to the files. Perfect. If there is this file list with that file name, then we have to do something. And so here we have to deal with conflicts, right? So I try and add a file. The name already exists. I have to manage that somehow, but I put it in. So we come up with our method signature, right? So I add a file. I know my file name and I know my file, but I don't know my file type, right? So it's again just a question mark of F. First thing here is to check for conflicts. So I think here, like, we'll quickly talk, but hash map is a type of class and it has methods available to it. One of the methods is exactly if exists or contains key, right? So this is essentially like I type in my key, which in this case will be file name, and I do something else, I know it does not exist, right? So yep, I do something to do, else what do? I add it in, right? So let's quickly do that. So else I add in my file, and you can kind of imagine files has another method called put, which is exactly that. So I put my file name and then I put my file. Perfect. And now this to do is the other part of the question. So what does it ask for? It should add a 1 onto the end of the file's file name. Maybe let's just quickly skip this implementation and you can have a go, but let's talk about it. So first thing you have to do is check if the file exists, which we have. Then if it does exist, we need to modify its key. So we need to get its key, update the key, and then put it back. So there's going to be a delete operation in here of the existing file and then a put of the new file. But maybe just comment that in, and then we can skip the actual. So you can have a look at the syntax for implementing this, but we add a file with an additional 1 on the file name. So you have to modify the file name, delete the old file, add the new file name. Is that clear to everyone what it's asking? Yeah? Okay. Do you want to go over this or are you happy to skip? Or we can go over. I'm seeing unsure. Do you understand what this would look like? Yeah? Okay. So I don't think we need to go over it, but we can. Okay. So you'll just do that there, and then that's what it's asking. Perfect. And then the next part of the question is a new method called add file. It takes a string, and then here, right, if it exists, replace it with this file. Yeah. So here before we were updating, so an update, maybe there's an update method or a delete or an add. Here we just replace, right? So we don't need to do the same check. We just put it in, and if there's something there, we don't really care if it's a collision. Perfect. Right. So here we're just putting, we're not checking if it's there already. So by default, this put method will just override what's ever there. And that's part of the sort of the hash map implementation. Okay. Any questions around this? All okay? Or all very confused? All okay? Okay. All right. Shall we quickly go to the last question? And I know we're probably throwing the more trickier things. So this would be like towards the end of exam, you might get a question about generics. You might get a question about implementation of generics. covering it here. So at least when you see it, if you're confident with everything we showed in that question minus the generics part, that's still quite good, right? So you should know how to kind of create classes, what that looks like, what inheritance looks like, how you can implement different things, maybe have a bit of familiarity with some of these inherit data structures. So we saw hash maps, but the other one is lists or array lists. So just knowing what methods are available and what those structures look like, all of that is a fantastic start. And then the only other like additional is this generics that we just shown. But if you can just even remember this and the syntax, and then you could get lucky and it's in the exam, in which case, well done. But yeah, it is the more complicated side of the subject.
Something I want to highlight in terms of like, this is something that quite often catches people out in semesters and during the exam. And they'd be like, during the semester, they'd be like, oh, IntelliJ fills out all these method signatures for me. So like, I don't even need to remember them. Well, unfortunately for the exam, you do. So that's one of the reasons why one of the slides that we had up previously was having up those data structures. So that would be hash map and set, I believe, is the other one that you probably should know. Okay, those two are the ones that you should actually at least go about knowing how to go about using. Okay, and how do you actually go about, let's say, adding into those particular methods. So for lists, it's pretty easy. It's just going dot add, and it will just add it to the lists. Whereas for hash maps, there's no add method in there technically. Okay, instead we use the alternative which they name as in put. Okay, you would need to remember those method names such as put, contains key, okay, remove, so on and so forth, given that it's probably going to be a common question that's going to be popping up on the exam. Okay, I understand that, I don't know, handwriting code may not be the best. It's probably not the most realistic because everyone, I mean, who hand writes code? Like you're using your IDE to write up your code, but that is the exam that you're probably going to get. Okay. Cool. So again, this last question is by far the most sort of like wordy and probably the most involved out of all the questions. And that's why we left it as last. Okay, so hopefully get you guys ramped up through all the other questions. So this question will involve everything that we talked about in question 1. So identifying what exactly new classes that we need to go about creating, what methods do we need to go about creating, but also this question goes a little bit into design patterns as well. Okay, so again, give you guys a couple of minutes to go through this. Okay, and then we'll come back and talk through solutions on this as well. Okay, and feel free to ask any questions that you may have. Okay, any burning questions, Rob and I are more than happy to try and answer these.
Yeah, like maybe we should just have a quick talk about time.
Yeah.
So it's almost 3 o'clock now. We've got one more question, and I think Charlie and I, we're happy to stay back a little bit so we can run over. Conscious everyone's time is precious. So I think maybe we can take a poll. We could either just talk about how we would do this question and you can take it home, have a go, have a look at the sample solutions, or we can just put this on ice and maybe take some questions or talk about exam tips, or we can also call it if everyone needs to run. So is there a preference here about what you want to do with the last couple of minutes we have? And are you happy to run over? Maybe I should start there. Is everyone happy to stay another 5 minutes? Yeah? Okay. And then do you want to talk about this question? Yeah? Okay. Do you want to read the question and then we talk about it, or we just jump in? Okay. I'm talking for no reason. I'll let you get back to it.
I did Java, so I learned Java and by sorry, it's something that I started when I started okay, that's giving me a lot of work for the same. It's like that's a very small thing. I don't know if you want to start with but
All right. So, oops, that was quite loud. Okay. So, in the interest of time, okay, so I'm only going to be going through the sort of the first three parts towards this question, which is primarily targeted towards, I guess, the design pattern part of side and also talking through, I guess, inheritance and also enums as well. Okay, so let's talk through asks of the question. What exactly is this question asking for? Okay, so this is kind of small, so hopefully you guys can see. Okay, but the very first ask is that we need to go about first creating an abstract class called currency. Okay, a currency named AVAX and a currency named ETH that both inherit from the class currency. Okay, so there are two main things from here. Okay, in terms of takeaways and syntax. Okay, one, okay, that parent class currency that we create needs to have the abstract keyword in front of it. You will notice that inside first this one, I created a class called main, that is public class main. Just a quick one, how do we make this main class abstract? Where would I be putting that keyword of abstract inside here? After public, thank you. That's all I needed to hear. Okay, so in order to make some particular currency, or sorry, not currency, some particular class abstract, okay, you would be placing that abstract keyword inside currency here. So we'd be already created and gone ahead and created some class ahead of time. So this will be the currency. Thank you, Rob. That'll be the abstract class currency in this particular case. Okay, so if we keep reading on, we also note that the currency class itself needs to have an attribute called type, price, and its type should be of double. Okay, so again, we'll follow our typical sort of like visibility standards. We'll set that particular variable as private, okay, and then we'll have its type of double. Okay, just for like our future needs and purposes, we'll also need to put in our getters and setters as well, but I'm sure everyone is quite aware of the sort of syntax behind getters and setters. Okay, so I'm not going to go diving too much into detail in terms of both of those. Okay, but the hard part is the question does ask us to create two subclasses from this particular class currency. That is ETH, okay, as well as AVAX itself. Okay, so both of those, okay, seem to be okay. So all we need to go about doing is creating those two new classes. So we say public class ETH, okay, and how do we make sure that a class inherits from another class? What's the keyword that we like to use? Extends. Thank you. Okay, so in the very next tab, we have those two classes created for us. Okay, the main thing is that we need to say that, hey, public class ETH extends currency, and then wabam. Okay, this class is now extending currency. Okay, but there is one trick thing that the question is asking for. Okay, can anyone tell me what that trick thing is? I'll give you a clue. It's got to do with the number 1. Okay. So the very last two sentences that it's talking about here, it's saying that please design the AVAX class such that the method avax.getInstance is called. It returns the same instance of the type AVAX. Okay. This is a callback, okay, to our design pattern called the singleton design pattern. So coming back to what that design pattern was used for, that singleton design pattern is used whenever we want to have one single, okay, object ever created, okay, and we also want to ensure global access to it, okay. So in terms of its implementation, there are three main things that we actually need to go about doing. Okay, the first one is that setting a static variable that is ETH instance. Okay, sorry, the font's a little bit small, so hopefully you guys can see. Okay, but why do we set this particular thing as static? Why can't I just have it as a, I don't know, non-static variable within my class here? Exactly. So if I let that attribute belong to a specific instance, that means I would be able to, okay, I am capable, okay, of creating multiple instances of this ETH, and as a result, violates the whole point of what we're trying to do here. We're trying to only create one single thing, one single attribute, and that is why we set that particular variable as static. Okay, so that instance variable should be a static, so private static ETH instance, okay, and then wabam. Second thing, okay, is that we will need to have our getInstance method, okay? This will be a static method because we want it to be available without needing to actually create the instance itself, okay? Hopefully everyone is aware in terms of how we go about calling our static methods, because I believe they show it in the question. Yes, they do. Okay. So whenever they call the method avax.getInstance, okay, are we instantiating an avax instance there? No, we're not. We're calling the class directly itself and then calling its static method directly from there. Okay. That's something really important to remember. Any static method that you want to go about referencing, you do not call it, okay, or you shouldn't try to call it directly from the object itself. It is called from a class reference itself, okay? All right. So this static method, in terms of its implementation, it's reasonably straightforward in the sense that all you need to do is first check if my variable or attribute has already been instantiated or not. So if it hasn't already been instantiated and it's the first time you're calling this method get instance, we need to go about creating that instance right then and there. So that's what this if statement is trying to do. If instance is equal to null, that means it hasn't been instantiated just yet. Okay, then we then assign the value to be new ETH and then return instance right there. So that will be returning to you the same instance every time. Okay. There is one more thing to take note because, I mean, here it doesn't really particularly matter because, I mean, it's just a blank constructor. But generally, when we're creating this singleton by itself, we will be creating a constructor of our own. We'll be adding in different variables, adding in different stuff, okay? But something to note, okay, about this constructor. Generally, most of the time, we just go public ETH and then putting all our variables, okay? Would that be correct when we're using, or would that be, I don't know, usable in the sense of singletons? Because if we were to create, okay, I don't know, a public constructor in this particular case, okay, so Rob, if you could just create one with some dummy variables inside, okay, so here, let's say we go public ETH, super, whatever, okay, let's put in the variables string inside the constructor for me. Name, yeah, sure. Okay. So in this particular instance, I've created a public constructor that takes in a name. But now if we go back down to my main method down at the very bottom, I can actually go about calling this constructor where that now I can actually create multiple instances of this ETH class. Is this what we wanted? No. The whole point of the singleton design pattern is to ensure that any instance that is of ETH of this particular class is that same shared instance, okay, that we've been reusing the whole time. And that is this instance variable here, okay? So something to note that when we're using the singleton design pattern, if we want to make sure that we're using the shared instance all of the time, okay, that is why we would generally set this particular constructor as private. Setting that constructor as private will not only make sure that it is only being used as intended, okay, as such within the get instance method, okay, and make sure no one else can go about instantiating or creating new objects of this ETH class, okay? So as a result, that's generally what should happen. And then within our sort of main method itself, this ETH works because the main method is inside the class itself. But if we were to move this main method into another class, this would no longer work. And that shared instance that we have defined in the main method right now would be your port of call in order to get your ETH object itself. Okay, so it will be ETH.getInstance. Okay, all right. Any questions regarding the use and implementation of the singleton method? Nope. Okay. So this is how you would go about implementing the singleton design pattern. Of course, there's other ways. I'm sure that you maybe need to go about implementing the strategy or template design patterns. Okay. This would need to be replicated for the AVAX class as well. Okay. So do the copy paste, same thing over here. I'm not going to go into too much detail in this regard. Okay. And the final two parts. So the question does ask, okay, that we also need to go about implementing an enum, okay, that is of transfer type. Okay. Can anyone remind me why should we create enums? Why do we need enums when we can just create a new class instead? Enums are specifically used for the purpose when we have a fixed and known set of values, okay? Rather than just creating a class that has all the different sort of values and attributes within it, we instead create enums that set out and list out all of our required types. So in this particular case, okay, we want to have different transfer types. We want to be able to send and deposit different currencies. Okay, so for the moment, we can go about just defining deposit and send within our transfer type enum as we've shown here. Okay, and in the future, let's say we want to enable some different transfer type that is withdraw. We can just go about adding it right at the bottom saying withdraw down at the very bottom, and we can continue extending upon this particular use case just like that. Okay. All right. Okay. And last but not least, oh, question. Ah, good point, Rob. Okay. So something that is, I guess, in terms of, I guess, convention. Okay. When we're defining constant like variables, okay, hopefully everyone is aware. I know as part of Java, there's a lot of naming conventions, how we should be going about, okay, are we using camel case? Are we using Pascal case? So on and so forth. Okay. When we're using enums, please ensure that we keep our enums as all capitals. So following the same convention as if you were going about defining a constant. Okay, if you have some particular constant defined within your game, okay, you would need to make sure you're following everything as capital case. Okay, and if there was a space in between, you would use that underscore, okay, to represent a space in between different words. Okay, so this will be following the same thing for enums as well. Okay. So that will be another example of payout. All right, okay. And last but not least, we need to create a class called history. This is supposed to record the performed operations. So we said that we need to be able to perform operations such as deposit and the send, and then essentially be the object or Java class that goes about tracking that. Okay, so within our history class that we have in the next tab, okay, can anyone tell me what specific attributes that I need to have for this history class? Fire it at me. I'm sure everyone knows. Just by reading. Any of them? Date time as one of them. Okay. Not quite. Not transaction date time, at least for the question. At least, I mean, of course, generally when you guys go about having a bank transaction, you would need to know what time it is. But unfortunately, this is not real life. And this is just some virtual world that we've created. So just something to note, it does say that within the question itself that the history class needs to take care of the currency in which it is transacting. It also talks about the quantity, so the number of currencies that we're dealing with, as well as the type of transfer or transaction that we're dealing with. So those would be our three main sort of, I don't know, our attributes within our class. But something to note here. We've talked about previously that our currencies can be of all different types. Here, can anyone tell me why have I listed my currency attribute as the parent class, currency? Why can't I just list it as, for example, AVAX? And then have another one called ETH? Why would I go with either one of the two? Is it better to do it one way or another? So this comes back to the point of why we actually go about using parent classes in themselves. Okay, it's to exactly avoid this particular scenario of having to store this whole giant list of all the possible different combinations that I can put inside this variable. Okay, because clearly currencies in the future, I'm not going to be limited to just those two currencies. Maybe in the future, I want to add Australian dollars to it. Maybe in the future, I want to add Bitcoin to this. Okay. If we use that second option down there, every single time you going about adding a new specific currency, I need to go into this specific class and add that new attribute to ensure that it actually goes about allowing that capability. Whereas if we kept it and abstracted a lot of that away and kept it as the parent class, as we've defined in that first line just there, okay, we don't even need to touch this code. Okay, it is kept, it is not even coupled in any way, shape, or sense here. Okay, and it is right then and there, dusted, done. Okay, so that is the wonderful nature of polymorphism and object-oriented coding. Okay, all right, so that brings a wrap. I'm being very, very conscious of everyone's time here. We've run 20 minutes over time. Okay, so thank you everyone, okay, for coming along to the revision workshop, and hopefully everyone's taken away some things that you may not have known, maybe, okay, prior to this workshop. Me and Rob are more than happy to stay afterwards for another, I don't know, however long you guys may have in terms of questions. We're here to try and help you guys out. I understand that we didn't actually end up going through all the different sort of agendas and topics that we wanted to, but me and Rob are more than happy to stay behind to answer any burning questions that you guys may have. Any final notes from Madam Chair?
Yes. Let me just pivot back over to our other slides. Great.
Well, first of all, I think we'd all owe both Rob and Charlie a massive round of applause for walking us through all of that. We appreciate all of the time that you've generously given up, as well as walking through everything so thoroughly. Now, to everyone else who's attended, it'd be amazing if you guys could fill out these feedback forms and have another stab at the link tree if you didn't get to look at it earlier. We're running events like these all of the time, every single week. Free coffee, industry catch-ups, upskilling sessions like this, and revision content. And it'd be amazing to see you there. Membership's free. And yeah, we hope that today's helped you feel a little bit more prepared for your exams. And if there is more subjects that you have yet to have an exam for, we have more workshops on today and tomorrow. So maybe we'll see you there. All right. That other way, I think we are a little bit over time. So that'll be it. Have a great day, everyone.
Thank you.
Have a good one.
For those online, I've just switched the screen sharing so that you can look at the QR codes. Thanks, guys.